Hello guys, Acto here, and welcome to Futuristic Combo Lock. This is what the module will look like. It will just be this sort of grayscale circle with a number in the middle on the black circle. Not much more to say about how it looks. Let's just get into how the module works now. So we're going to be using this number and pretty much all of the edge work to create a number string, and then we're going to manipulate that number string to get a code that we need to put into this combo lock. So let's start with generating that digit sequence. The first digit is going to be the left-hand digit on the module here. So we have 8. And then we just follow this box along until we get to the last digit. So first we have number of modules on the bottom, including needies. In this case, that is just the 1. Then we have number of minutes that are on the bottom when the lights turned on. If you didn't see, that was 120. Number of batteries on the bottom, we have 5 of those. Followed by number of battery holders on the bottom, there are 3 of those. Now these 3 boxes are going to be the more interesting ones. For every indicator present, we have only 1. But we first start off with its sort of status. So in this case, it's either lit or unlit. This FRQ is unlit, so we're going to put 0 first. And then we're going to convert the rest of the letters via A1Z26. So F is 6, R is 18, and Q is 17. And just in case you have multiple indicators, lits come before unlits, and it prioritizes alphabetical order. So FRQ will come before S and D, unless that S and D is lit, which then it becomes full before the unlit FRQ, basically. Next we have port plates. We're going to be using these 2 Venn diagrams here, which corresponds to the 2 different types of port plates you can have, serial parallel and the PS2 RTA RJ DVI port plates. We're going to be finding what ports are on the plate, where the Roman numeral in the position is going to be telling us what order to put them in. That won't matter in this case, because we only have 1 port plate, but you then just put them in order of the Roman numerals, I, IV, and so on. And then, of course, if you have duplicates, they both have the same numbers, you just duplicate it over. So, our port plate we have is a singular port plate with just a PS2 port on it. So, that is going to be here. Yeah. So we can ignore the Roman numeral here because we already have 1. And the number we're going to put in is 1, 2. And next we have, for every serial number character, it's pretty simple, this one. Convert the letters with A1 to Z26 and numbers stay as they are. So I is 9, C is 3, 4 is 4, A is 1, X is 24, and 7 is 7. So, and then don't forget to put on the last digit of the number on the module again. So now we have our number string. What do we do with it? We're going to be doing some back and forth conversion. So if this is our first run through of the list, we're going to process the digits from left to right. And then on each subsequent one, we swap directions. So in other words, on every odd pass through, we're going left to right. On every even pass through, we're going from right to left. Sometimes it doesn't make a difference, but it's very important because there are cases where it does make a difference. So, and also, we'll probably get to a point where we'll have alternating between odd and even digits. We'll see in a minute why that's important that we don't get that. Mainly because we're going to be using the parity of both digits being the same. And of course, if they alternate, you're not going to have them both be the same at any point, so you can't reduce it down anymore. So in that case, we're going to change the middle digit or digits if we have an even number of digits at that point to make it so it's not that, basically. I'll explain it again when we get to it. So we're going to start with the first pair of digits and check if they have the same parity. The same parity being evenness or oddness. So basically 1, 3, 5, 7 and 9 are odd, and in this case 2, 4, 6 and 8 are even, and so is 0. So if the parity matches, we're going to use the wheel. Otherwise we just ignore it and then shift everything once over, not to the next pair, just everything one over. So in this case, 8 and 1, these don't have the same parity, so we can move it over 1 and we know the 8 stays as it is. 1 and 1 have the same parity, so we can pair those up. 2 and 0 have the same. 5 and 3 have the same. 0 and 6 have the same. 1 and 8 don't. 8 and 1 don't. 1 and 7 don't. 1 and 7 do even. 1 and 2 don't. 2 and 9 don't. 9 and 3 do. 4 and 1 doesn't. 1 and 2 doesn't. 2 and 4 and 7 and 7. 2 and 4 and 7 and 7 do for their respective pairs. So what do we do with this? We now, for every pair, we're going to use the wheel, and we're going to find the smallest set of wedges, so either clockwise or counterclockwise, to get from one digit to the other one. And this direction, we find the one in the middle. This is important why they're the same parity, because otherwise there wouldn't be a concrete middle one. Like if you had 0 and 1, there isn't anything between them on the shortest path. So we're going to take the middle digits. So for example, if we had 0 and 4, we would go 0, 1, 2, 3, 4. The middle of that would have been 2. So a 0, 4 or a 4, 0 would become a 2. So let's go through each of these. So 8 stays as it is. 1 to 1 stays of 1. 2 to 0, that is going from here to here. The middle one being 1. 5 to 3, we get 4. 0 to 6, we get 8 here. 1 stays as is, 8 stays as is. 1 and 7, we have 9. 1 and 2 stay as they are. 9 and 3 becomes 1. 4 and 1 stay as they are. Next we have 2 and 4. Middle one is 3. And then finally we have 7 and 7, which is 7. So we have done one iteration of this. And if you remember what I said, we're now going to go back the other way for this one. So we're actually going to start at the right hand side now and pair them up going the other way. So 7 and 3, those match in parity, so we can pair those. 1 and 4 don't. 4 and 1 doesn't. 1 and 2, 2 and 1. 1 and 9 do. These don't. These don't. These do. These do. And now you can see why the direction does make a difference, because there's a chance that the 1 and the 3 would have been paired up instead. Okay. And now let's do the same we did again. 8 becomes 8. 1 and 1 becomes 1 again. 4 and 8 becomes 6. 1 and 8 stay as they are. 9 and 1 becomes 0. 2, 1, 4, 1. And then 3 and 7 becomes 5. And now we got to this iteration. We're now odd iteration, so we're going from left to right again. And we just repeat this process until we're down to 5 digits. The exact moment you hit 5 digits, you move on to the final step. So going from left to right again. No, 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 yes. No, 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 no. So we only have one conversion to do here. Which 8 and 0 becomes 9. 8, 1, 6, 1, 9, 2, 1, 4, 1, 5. Going from... Oh no, wait, I'm being stupid. 1 and the 5 pair up here as well. Because so the 1 and the 5 become 3. Let me just check I haven't made any more mistakes. Okay, I think I'm glad I spotted that. So now going from right to left, since we're on an even one now. No, 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 yes, no, no. So 8, 1, 6, 1 and 9, as we've seen before, becomes 0. 2, 1, 4, 3. Going from left to right again. No, no, yes, no, no, no. 8, 1, 6 and 0 becomes 8. 2, 1, 4, 3. Going to even iteration, we're going from right to left. No, 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 yes, no. So 8, 1, 8 and 2 becomes 0. 1, 4, 3. And this is where we reach the point I was talking about. We are on 6 digits right now. But if we do the pairing up for this, going from left to right, no, 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 no. We can't make any more reductions. So what do we do here? If your sequence alternates between even and odd digits, convert the middle digit or digits to 9 minus that digit or digits. So the middle digits here will be the 0 and the 1 here. 9 minus 0 is 9. 9 minus 1 is 8. And then we carry on like this. Going from left to right. No, yes, yes, no. So we get 8. And we get 1, 9 here. Which gives us 0. And I don't think we end up converting this one because we've reached 5 digits now. We can completely ignore if this one even existed. Effectively, we're converting everything one at a time, and the exact moment, even if in the middle of a iteration, you get to 5, you ignore everything else and move on to the last step. So the code we're going to be inputting is 80843. So this wheel here is actually also how we input our numbers. We're going to click on the region we want and then alternating between clockwise and counterclockwise. We're going to go between each of the digits we need So in this case, we will click on 8 and then move up to 0, and then back to 8, counterclockwise, then clockwise to 4, then counterclockwise to 3. In the chance that you end up having the same digit next to each other, like 1, 1, you got to go a full loop round before you input the next one. So if we have 1 and 1, if we came from the clockwise direction the previous time, to input a second 1 consecutively, we had to go counterclockwise the whole way around to the 1 again. So hopefully if we've done this right, we should click on the 8 and it will stop spinning. Go clockwise to the 0. Do note you have to keep the click held the whole time. Then back to the 8. Then clockwise to the 4. And then counterclockwise to 3. And then we submit by deselecting the module, like fully deselecting the module. And if we get it right, it will unlock. If we get it wrong, it will do a sort of resetting sound, but it will not strike. And we get self module. Deselecting, of course, going back to this sort of thing. So, just to go over some little things again. Even though I was doing most of this as sort of like full iterations going throughout every single time, keep an eye on the exact moment where a sort of split, when you're splitting it, and the exact moment you get to 5 digits, even if you're mid converting stuff, you go to the last step. So in this case, if we converted both of these, we would have ended up with 8063, and there's no way to get more digits afterwards. So we would have gone too far at that point. Hopefully that makes sense of what I'm saying. Just basically, I'm doing all these as singular steps, the entire conversion, but in reality, every single pair conversion is its own step, if that makes sense. And then just be careful with converting the indicators and the port plates into digits, and don't forget to put the first and last digits on either side. So now, like I said, your input will not be considered valid. Actually, this is something I forgot to say. Your input will not be considered valid if the in-between regions were not hovered over in the right order. So you can't like go across the middle to get to different places. You have to go round as if you are physically rotating a lock, basically. And like I said, failure to input the correct combination will make a resetting sound but will not strike, similar to normal combination lock. So hopefully futuristic combo lock makes a bit more sense now. And I'll see you guys in the next tutorial. I'll see you later.